Hey everyone, welcome back to LabCoatz. So, a while back, I decided it would be kind of fun to try and synthesize dopamine. You know, the neurotransmitter in your brain that makes you feel happy and stuff. I even came up with my own synthesis pathway and everything. But then another guy beat me to it. And that kinda sucks. Still, his pathway is somewhat different from my own, and since mine has actually been verified by scientific papers, I'm still going to go through with it and give it a shot. But in order for me to do that, I'm going to need the right ingredients. And one of those is a chemical called nitromethane. Now, at least in the United States, nitromethane isn't a super restricted chemical. However, since it does find use in certain explosive compositions, most mainstream sellers like Amazon don't appear to be very comfortable selling it in its pure form. So what's the solution? Well, one option would be to synthesize it, but to me, that didn't seem very practical. The chloroacetic acid and sodium nitrite used to make it are both hard to find and somewhat expensive. And plus, the yields aren't exactly anything to write home about. So instead, I decided to distill my nitromethane from a pre-existing source, RC Nitro Fuel. Now, the nitro sold on Amazon is typically no more than 30%, with the most common concentration being 20%. I personally bought a liter of VP's Nitro Racing Fuel, since it was the only variety I could find a decent datasheet for. Composition-wise, this stuff is roughly 20% nitromethane, 71% methanol, and 9% oil, with the oil apparently being a mixture of castor oil and a propylene oxide polymer, such as polypropylene glycol. In theory, distilling both the methanol and nitromethane off the higher boiling oil should be fairly straightforward. However, there is one small catch. Nitromethane actually forms an azeotrope with methanol, meaning some of the nitromethane will inevitably be lost in the methanol fraction that boils off first. This did concern me a little, but given that the azeotrope is only 9% nitromethane and my starting mixture was 20%, I felt fairly confident that I'd obtain at least some purified nitromethane. So, to start, I measured out roughly 250 milliliters of fuel and added it to a 500 milliliter round bottom flask, along with a stir bar to help things boil smoothly. Then, I insulated the flask with glass wool and set up for a fractional distillation. As I found out from later runs, the long fractionating column isn't actually necessary to obtain good separation of the nitromethane, and if anything, it just slows down the process. So if you try this yourself for some reason, I recommend running a simple distillation. As things began to boil, I connected my digital thermocouple to monitor the vapor temperature. For the majority of this process, the temperature doesn't really exceed 70 degrees Celsius, but once most of the distillate has been collected, things heat up pretty quickly. Within 5 minutes, the thermometer jumped from 65 degrees to nearly 100 degrees Celsius, and at this point, I swapped out my receiving flask to collect the nitromethane. In no time, the temperature plateaued at 101.2 degrees, which is pretty much the exact boiling point of nitromethane. I kept collecting until the distillation slowed, and in the end, I had a few milliliters of a nice, clear liquid. All that remained in the boiling flask was a viscous brown oil with a very high boiling point, which I subsequently discarded. So, since everything seemed to have worked, I decided to distill the remaining fuel and isolate as much nitromethane as I could. It was a long process, despite me switching over to simple distillation, but after all my work, I was rewarded with almost 20 milliliters of crystal clear nitromethane, along with almost a liter of methanol nitromethane azeotrope, which I'll be saving and using as a handy cleaning solvent for my glassware. Now, I could have stopped here, but since I wanted to make the purest dopamine possible, I decided to redistill my product. This time, I ran things a bit more slowly and only collected the distillate that came over above 100 degrees Celsius. The result was 17 milliliters of a liquid weighing 18.43 grams. This means that the density was right around 1.08 grams per mil, which is pretty close to the theoretical 1.14 mentioned in literature. I probably would have gotten a pure product if I'd only collected after 101 degrees Celsius, but oh well. This is still good enough for most applications, especially my dopamine synthesis, since it'll need to be diluted in alcohol anyway. Now, let's do one final crude test to see if we're actually working with concentrated nitromethane. I've scooped out a bit of sodium hydroxide onto this overturned beaker, and now I'll add a few drops of the distillate. Perfect. Nitromethane forms unstable salts in the presence of strong bases, and if the nitromethane is pure enough, it will auto-ignite. This does tell me that the distillate is fairly concentrated, but to be honest, I mostly just did this test for fun. So, there you have it. You can indeed distill nitromethane out of low-grade Amazon RC fuel. Granted, you won't be getting liters of nitro using this route, but if you only need a small amount for a couple experiments, this method does seem fairly useful. As I mentioned before, I'll be using the nitromethane I obtained in an upcoming project, where I chemically synthesize pure dopamine, so be sure to stick around for that video. And if you'd like to help support me and my work, consider donating or becoming my patron on Patreon. The links, as always, are down below. A special thanks goes out to all the dedicated LabCoatz supporters. Without the generosity of these people, I wouldn't be able to afford a lot of the cool stuff I do, so I'm truly grateful for their support. Remember to like, share, and subscribe, and I'll catch you next time. LabCoatz out.